In this next section, we'll be looking at other rates of change, primarily ones dealing with economics problems. So we'll be dealing with something called marginal cost and marginal revenue. Now, marginal cost basically is the derivative of the cost function, but what it's looking at is the rate of change of cost with respect to the production. One way we can think about this would be the cost of making one more unit. The marginal revenue will be the rate of change of revenue with respect to production, so it's the derivative of the revenue function, or the amount of additional revenue we would receive from producing or selling one more unit. We can also think about profit as revenue minus cost, which might come in a little bit later. And we can think about this, let's say in your senior economics problem you decided to sell cupcakes. Now, to start selling cupcakes, you'll first need some things like ovens and pans, and so let's say that costs you 3,000 baht to get started. And then actual materials to make each cupcake is only 10 baht. So we can make a formula for our cost of making X cupcakes as being our startup cost plus 10 baht per cupcake. The cost then of 100 cupcakes would be about 4,000 baht, and the cost of making 200 cupcakes would be about 5,000 baht. Now, if we think about average cost, then the average cost of making one cupcake is going to depend on how much we make because of the high startup costs. So if we start with our 100 cupcakes, the average cost of making 100 cupcakes would be about 40 baht per cupcake. If we increase our production to 200 cupcakes though, that's going to decrease our average cost dramatically from 40 to 25 baht per cupcake. And so we're at an advantage of making a lot more cupcakes because that will bring our overall cost down. On the other hand, marginal cost is looking at the cost of one cupcake. In this particular case, it cost me 10 baht to make one cupcake. So the cost of making one more cupcake is 10 baht per cupcake. There are advantages and disadvantages to using each one. The advantage of using average cost is it helps us see how the cost is going down as we go on. The thing with marginal cost though, in this particular situation, this is a linear function, so it's always going to be 10 baht per cupcake. But in some situations, our marginal cost will actually be changing as the level of production changes. We need to think of our marginal cost as something that changes because if we look, for example, at this situation, we might reach a level of production where one oven is no longer enough. And if we need to purchase another oven, that'll give us higher costs. And so we might reach a level in our production where we need to kind of stop or else we're going to have another big jump in the average cost. So here's a problem dealing with marginal cost and marginal revenue. Here we have a nice function for our cost in dollars produced when 8 to 10 radiators are produced. Now the reason they throw this 8 to 10 radiators is because a lot of times in a problem like this it's only reasonable to think about this within a certain context. For example, maybe the shop only has the staff or the facilities to handle a certain amount of production, a certain level of production, and so this function is only reasonable between those values. And so if we want to think about the marginal cost and marginal revenue, we're simply taking the derivative of each of these. And both of these can be worked out with the power rule. And if we want to find that average cost at 10 radiators a day, we just plug in 10. So we get 195, and our units here, since we were measuring X, and since X was our radiators, and cost was the number of dollars, then our units would be dollars per radiator. Marginal revenue will be the same sort of thing. We take the derivative of the revenue function. We have 3x squared minus 6x plus 12. And we want to find that at 10 radiators a day, which is going to give us 252. And again, our units will be dollars per radiator. Another thing that this section touches on very briefly is something called sensitivity to change, which is just talking about how small changes in X are going to change, how dramatically they're going to change our function. So if we look here, we have a rather large jump at the beginning from these values of X, whereas later on the same amount of change for X is going to produce a much smaller amount of change. So we would say that over here it's more sensitive and over here it's less sensitive. And since we're basically looking at the slope here to decide how sensitive it is to change, we can use the derivative to measure the sensitivity.